Sí, normalmente damos 5 minutos, Luisa, pero no sé, ¿quiere que empecemos antes hoy?
Sí, ya hay muchos conectados, ya están muchos de ellos.
Sí, sí, claro, hoy va a haber mucha gente. Pero creo que esto de dar siempre 5 minutos hace que todo el mundo sepa que empezamos 5 minutos tarde. Bueno.
Solo la presentación se podría poner en pantalla completa porque se ven las siguientes las notas y eso.
¿Es para Chris?
Sí, le estaba diciendo a Chris. eh, eh,
Chris, can
eh,
you make your full screen
Presentation.
presentation?
I think so. Let me see if I can do it here.
Okay, that's right.
Is that better?
Yes.
Yes, yes.
Okay. Okay, great.
Okay. Bueno, vamos a comenzar, Luisa.
Ok, sí.
Okay, good morning, Dr. Christopher Landsea. Welcome to CICESE, to the seminar of Department of Physical Oceanography. We're very happy that you are with us. We asked to Dr. Chris Farfan, Dr. Chris College, to introduce to Dr. Chris to the audience. Thank you, Dr. Luisa. Go ahead.
Sí, buenos días. Voy a hacer esto brevemente en español. Tenemos el agrado de contar con el doctor Chris Landsea del Centro Nacional de Huracanes de Estados Unidos. Él cuenta con estudios de licenciatura en la Universidad de California en Los Ángeles, maestría y doctorado en la Universidad del Estado de Colorado. Sus estudios de posgrado fueron bajo la dirección del profesor William Gray, uno de los pioneros de la meteorología tropical y estudios de huracanes. Dentro de las áreas de interés de Chris está el pronóstico de huracanes a escala estacional, la variabilidad y cambio climático asociada a huracanes y proyectos donde hay aplicación de pronósticos del tiempo. Parte de sus logros, entre otros, él ha participado en proyectos de campo relacionados a investigación y pronóstico de ciclones tropicales. Es donde utilizan o se utiliza como herramienta importante los aviones cazahuracanes que tiene el gobierno de Estados Unidos. Ha escrito más de 60 artículos científicos y capítulos de libro y ha recibido varios reconocimientos del gobierno federal de Estados Unidos por sus resultados del trabajo que ha realizado y también premios por parte de la Sociedad Americana de Meteorología, de la cual él es miembro del consejo editorial del boletín de la Sociedad Americana de Meteorología en el área de meteorología tropical y huracanes, y entre otras áreas que está encargado en el Centro Nacional de Huracanes, maneja la base de datos histórica que muchos de nosotros utilizamos cuando queremos saber por dónde se fue un huracán de temporadas pasadas. Esta base de datos contiene posición, intensidad de huracanes en el Atlántico. Inicia desde 1851, en el Pacífico desde 1949. Chris, thanks for being in today's seminar. We are all yours. Thank you.
All right. Thank you very much, Luis. I appreciate it. No hablo o entiendo mucho en español, un poquito, nada más. But I do have a small story about how my Spanish speaking got me in trouble. Several years ago, I got to go to Spain, and we visited the beautiful city of Toledo, up in the mountains. And my wife, my niño, 2 años, we got to the hotel, and there was only one bed. That's a problem. 3 people, only one bed. So I said, no problema, to my wife. I will call the hotel operator and ask them to send a bed to our room for our son. And so I pick up the phone. I say, buenas noches, señora. Necesitamos una dama para mi niño. Of course, I meant to say cama, no dama. And so that was a problem. I heard ¿qué? And so fortunately they did not send a woman, they sent a bed. That was good. Yes, so my Spanish can get me in trouble sometimes. So what I'm going to chat with you about today is hurricanes and global warming. And I'm going to set the stage of kind of expectations of what we think may happen from the climate models versus observations of what we think we know of our records. And even though I work at the National Hurricane Center, and that's part of the U.S. National Weather Service, and it's part of NOAA, National Oceanic and Atmospheric Administration, this is not a policy talk. This is my perspective on someone who's worked in the field for a few decades. So any opinions are mine. It's not a policy talk. So hurricanes and global warming get a lot of attention. So a decade ago, it's amazing how quickly time flies, Hurricane Sandy was a huge system impacting the New York and New Jersey portions of the United States, and massive amounts of flooding and huge impacts. And at the time, there was a lot of people linking Hurricane Sandy to global warming in a periodical, and there was even protesters that were demanding that NOAA and other agencies end climate silence. And there's a lot of legitimate questions about what's happening. How is global warming affecting the numbers of storms, the strength of them, or what we call intensity, genesis, where they track, how much rainfall, the overall activity. So, but it's a little more complex and nuanced than one might get from just the general media. Or even these protesters. I do note these protesters had the hurricane spinning the wrong way. That's a cyclone in the southern hemisphere. That's the wrong way for up here in the United States and Mexico. So we're going to start then with a quiz, and everybody's got to vote. I can't see what you're going to vote for, but I do want to get your kind of opinion on it, and then we'll see what the answer is likely. So what are the most dangerous aspects of hurricanes? And so you got 4 different choices. The first choice is wind caused damage. And this is a picture I took after Hurricane Andrew hit Miami back in 1992, 30 years ago now. Is the impact most deadly from inland flooding? So rainfall induced flash floods and mudslides. Is the most deadly part storm surge, where it's the salt water flooding, why the winds are pushing the salt water ashore, or is it tornadoes? Okay, so everybody's got to vote. All right, so again, do you think it's wind caused damage, storm surge, tornadoes, or inland flooding? The answer might surprise you. A lot of folks would think it's the wind, but the wind only accounts for 5% of all the fatalities. And this is for the United States over a 50-year period. I suspect the rough percentages are similar for Mexico as well. But really, when you look at the totality of the fatalities, 85% are due to water, whether it's ships offshore, whether it's folks in the coastal zone, whether it's rainfall-induced flooding and mudslides, or storm surge. And so in the United States, it's actually been a little more than half is just due to the saltwater flooding. So Mexico, I think there'd be more on the rainfall-induced floods and mudslides and less on the storm surge. But certainly all these hazards are of most interest, but it's an important reminder that we really need to focus on the water hazards and not as much the wind hazards as far as potential for large loss of life. So a good way to push this point a bit further, this is a home just a few blocks from the beach in a town called Waveland, Mississippi in the United States. And perhaps if you were the owners, David and Kimberly King, and you lived in a town called Waveland, that would suggest there could be problems living there. And this is one day before Hurricane Katrina hit in 2005. And as very common, the day before a hurricane, it was beautiful weather because you're in a subsiding branch of the secondary circulation. And so completely clear skies. And they were told, you need to evacuate. You're in a storm surge area where you could drown. And so the Kings did the right thing by packing up their stuff, and they put shutters. You can see there are shutters they're about to put on their windows. And they left town. And when they came back, and it took them a month to get back because the authorities had closed off the entire coastline of Mississippi and Louisiana, this is all they had left. You can see they really didn't have anything. It was the house was completely carried away by storm surge that reached up to 4 or 5 meters of water above the ground, as well as winds reaching 150 to 175 kilometers per hour. So it was really a big impact event. They did the right thing. While they lost their possessions, they did save their lives. And unfortunately, some people in this neighborhood did not leave. And that was from a hurricane everyone knew was coming. It was a Category 5 the day before, and yet people did not leave. And this is a big concern as meteorologists to make sure that people are doing the right thing to avoid drowning when the storm surge comes ashore. And so this is an issue for all countries that get impacted by hurricanes. So when one looks at global warming itself, we want to start with the impacts, like storm surge and wind-caused damages. And if one just looks at raw damages, and the same is true for countries in the Caribbean and Central America and North America, not just the United States, but the raw damages have been going way up. And over the last century, even after you adjust for inflation, that a dollar or a peso can't buy as much today as it used to, you can see that the amounts of damage have gone way up. And so some folks have attributed this increased damages to global warming itself. And we'll get into the physics a bit more of global warming. But I think it's a little premature because there's other aspects that may cause damages to go up. And so here's quiz number 2. All right. What contributes most to these increased damages by hurricanes today? And so you got 3 options here on this quiz. All right. So again, I want you to vote, even though I can't see what your answer is going to be here. So do you think it is that there is increased wealth? So per person, per capita, that wealth is going up more than, for example, in general, in North America, we have twice as much goods and property as our parents did, and 4 times as much good as our grandparents. So per capita wealth, per person wealth is going up a lot. Is it increasing coastal populations? And some populations along the coast are doubling every generation. Or is it increasing numbers or intensities of hurricanes? So which of these three factors do you think is causing those increased damages, the main cause? Well, if you said B, you're right, because that's really the key. The populations are just going up tremendously because it's a great place to live. La Paz, for example, is a wonderful place to live, but occasionally you get hurricanes there. And so that's the impacts is when a hurricane hits, it's a very different coastline. And so, as I talked about with the wealth, that nowadays there's more income, more possessions that can get destroyed when a hurricane comes ashore. So that's one aspect. The other aspect is that the population keeps going way up. That you're ended up having, in this case, I'm showing a time series for Miami-Dade County, Florida. But the same is true for every state in Mexico and every country in Central America, that the populations are going way up, especially in the coastal zones, again, because it's a nice place to live 99% of the time. And so that makes it more difficult when a hurricane comes, because you want to evacuate all these people from away from the coast. And so that makes it more difficult to keep people safe when there's so many more people living on the coast. So one way one can address a little more homogeneously is to take the original damages and adjust them to take into account not just inflation, but for the coastal county population change over time and the per capita wealth change. And I've been involved with a few studies in the last couple decades where we tried to do this, what we call apples to apples comparison, a fair comparison of past hurricanes versus today. And when you do that, the time series is very different. Unlike the one that shows a big ramping up in damages, after you normalize, then in the United States, and again, the same is going to be true in Central America and Mexico, that there's no longer a big long-term trend in damages. Instead, what we see are multi-year changes, where there's some decades that are very damaging and some decades that are very quiet. And to me, this is actually showing us a little bit of real climate change in the impacts themselves. In this case, it's normalized damages once you're taking out the societal factors. Because damages themselves, they're such a function of what's the population at the coast and how is wealth changed in that particular area. And again, most times the coastal areas, and this is true U.S. and Mexico, coastal areas have more wealth, more infrastructure, more buildings, more tourists. So that's one way to look at it. But maybe you can say, well, that's economics. That's kind of a soft science. Let's do physical science. Let's look at the meteorology. And so we can use tools like global models and theory to look at how have hurricanes been changing over time. And so this is kind of a quiz before we start getting into what the physics and the science says. So how will global warming impact hurricanes and the maximum winds? Now, keep in mind that it is true that the sea surface temperatures, the air temperatures have been warming. And since the beginning of the industrial age, they've warmed up globally about 1 degree Celsius. So there is global warming, and we do see that occurring. And I would agree that this is an anthropogenic cause, so mankind caused because of carbon dioxide and methane. And hurricanes are heat engines. And so we know that the hurricanes feast off of the very warm, moist, sticky air that we have here in Miami and you have in La Paz that happens all year during the hurricane season primarily. And so it's taking that energy from the boundary layer, releasing it in the rain bands and the eye wall. Most of the energy leaves the system in cold exhaust because the hurricane is a heat engine. But a small portion of that heat remains locally, and the air warms, the pressure drops as the density drops, and the winds spin faster and faster to try to fill that low pressure void. So it does make physical sense that hurricanes would be stronger because of global warming. But I think it's important that we need to understand how much. What's the quantification? So here's the quiz. So let's assume a lot of global warming, maybe 3 or 4 degrees Celsius by the end of this century. How much stronger would hurricanes be because of that? Would it be double, 100% stronger? Would it be 50% stronger, 1/4, or 5%? So it's all the way from a doubling to a very small amount. Everybody vote? Well, the answer, it may surprise you, is only 5%. And that's a fairly small number. So put that in perspective today. What global warming theory and modeling suggests that even for hurricanes like Category 5 Hurricane Michael, that only 1 or 2 mile per hour of its peak winds could be ascribed to global warming. And so that's so small that we can't even measure it. Our precision in our database is 5 knots or 6 miles an hour. But the accuracy for Category 4s and 5s is much less than that, and so the accuracy is more like 10 or even 15 miles per hour, and so it's difficult to measure if it's with wind speed changes that are that small, only 1 or 2 miles per hour. So about 1% stronger today, and maybe by the end of this century 3 to 5%. So that's a fairly small change, and I think that's important to keep in mind because it's scary to link hurricanes to global warming. But I think when we start breaking it down and what does that actually mean, if we're looking at 3 to 5% stronger, 70 years from now, that's a long ways away, 80 years from now, and it's a fairly small change. So let me show you an example of a study that documented this, and this is representative of most studies that are out there today. So in blue is a distribution of tropical storm and hurricane winds going from tropical depression to tropical storm, Category 1, all the way up to Category 5. And the blue is in kind of the pre-industrial distribution of how many hurricanes they are at different wind speeds. And the red is what is anticipated to occur based on this study by the Geophysical Fluid Dynamics Lab in Princeton in the United States. And so there's a couple things to point out from this graph. The first is that as expected, as we have an intuition that there would be slightly stronger hurricanes. And so that tail shifts to the right a little bit. But it's fairly small. Again, it's only about 3 to 5% stronger for hurricanes at the end of this century, assuming quite a bit of global warming. The other thing to point out, and I should say why. The reason why is that it's not just the sea surface temperatures affecting things, it's the whole tropospheric profile, especially near the tropopause. And for every degree warming that we have at the ocean surface, there's a double or triple of that warming near the tropopause. So for dry static stability, it's actually more stable under global warming. But when we throw moisture in, we end up with slightly more unstable, slightly more energy, or CAPE, convective available potential energy. And so we go back to that. When you look at how the maximum potential intensity could change, it's roughly 1% stronger for each degree Celsius sea surface temperature. And some areas don't even show it. For example, in this one study by Gabe Vecchi and Brian Soden from GFDL and University of Miami, they actually suggest it could be less intense in some parts of the Atlantic and Caribbean. But in general, I think you can generalize to say about 1% stronger for each 1 degree Celsius change. So if we're looking at in the tropics, a 3 degree Celsius change in 70 years, then we're looking at about 3% stronger. That's that big, small. So what about numbers? All right, so how will numbers change? Because they're the intensity or the wind speeds, that's an important factor. But what about numbers? We're going to see a whole bunch more. So here's your options. Are we going to see 50% more, 1/4 more, no change, or 25% fewer. And again, the answer might surprise you. It's not more. It's not even no change. The best expectation right now is that global warming will produce fewer tropical storms and hurricanes, not more. And the reason why, again, we go back to this study, what they found, and again, blue is the control, pre-industrial, and red is at the end of the century, a big reduction in tropical storms, category 1s, 2s, maybe even category 3s. And so it's a sizable reduction. And as best we can tell, it's two factors. One is the vertical shear goes up, and hurricanes do not like vertical shear. So that's the difference between the lower tropospheric winds near 850 millibars and 200 millibars. So that kind of 1 kilometer to 12 kilometer distance in the troposphere, the shear is anticipated to go up. The other aspect is the mid-level moisture, that it looks like it'll be drier because of global warming in the tropics and subtropics, both of which make it more difficult to form, even if the thermodynamics are slightly more favorable. So somewhat contradictory results, all right? Quiz number 5. All right, so we're getting there. Hopefully I'm not blowing your brains too much here. So global warming and rainfall. So that's a big impact, especially where you have hilly and mountainous terrain and you have a slow-moving tropical storm or hurricane. You get massive amounts of rainfall and horrible impacts from rainfall and flash floods and mudslides. So again, what's your expectation in advance? Will hurricanes, because of global warming by the end of the century, cause double the rainfall? Will it be 50% more? Will it be 25% more, or only 10% more? And so again, it's important to quantify. We want to know the numbers, not just there's a linkage, but what's the relationship? And the relationship says 10% more. So it's when one looks at, even for Hurricane Harvey, as an example, that devastated parts of Texas with feet of rain, meters of rain. One can see that when we look at the projections of global warming from the climate models, that it's going to be roughly 10% more rain by the end of this century. And so what we've observed today is on the order of 3% more. So again, it's a fairly small change. The main reason for the massive flooding was that Harvey sat on top of Texas for a week. That's the main thing. In fact, we have an old rule of thumb that you take the hurricane's speed and divide it into 100, and you get the number of inches that's expected for that could occur. So if it's moving at 4 knots, then it would be expected to maybe have 25 inches of rain, which is about 0.7, 0.8 meters. So that's the big thing that causes extreme rainfall in tropical storms and hurricanes is slow movement. So again, it's not zero, but it sounds pretty small to me if this is in the right ballpark. What about storm surge? Well, storm surge, really, the impacts are going to go up based on the intensity and the size, but also sea level rise. So it's a little bit independent. If the hurricanes are a couple percent stronger or larger, then storm surge would be a couple percent stronger or larger. But if there's a 1 meter sea level rise because of global warming, every hurricane is going to have an extra 1 meter of sea level rise when the storm surge occurs from the hurricane making landfall. So to me, this is really the biggest. The intensities go up a little bit, the numbers go down, rainfall goes up a little bit. To me, this is the issue that's of most concern, is storm surge impacts, not because of the hurricane themselves, but because of the sea level rise that is anticipated to occur. Okay, so those are the expectations. So that's the subtitle of the talk. What are the expectations from hurricanes? And that's to use theory and modeling. with the global climate models to help us get a perspective on what could occur. Now, there's lots of uncertainty on all that. In fact, my old advisor, Bill Gray at Colorado State, hated climate models. He thought they were just notoriously unreliable because of how complex all the Earth, ocean, atmosphere system was. So what about the database? Why don't we just take a look at HERDAT, this hurricane database, and just count how often we have strong hurricanes, or count how many tropical storms we have. And one thing was that just 2 years ago, we had a record-breaking hurricane season. We had 30 named storms. That's tropical storms, subtropical storms, and hurricanes. That was a record. In the United States, we had 13 named storms making landfall. That was a record. We had a record of 7 of those being billion-dollar tropical cyclone damage events. So it was a really, really busy year. And the 30 named storms, that broke the record. If you look at from the hurricane database, going all the way back to the 1870s, you can see 2 outliers, 2005 and 2020, that really were unlike anything else ever seen. And you can see this long-term trend. So that curve shows kind of the multi-decadal to 100-year trend, where back in the 1870s, 1880s, there was in the database only on the average of 8 to 10 tropical storms and hurricanes a year. And the last 10 or 15 years, that's closer to 15 or 17. So the database shows a doubling in the number of tropical storms or hurricanes in 100 years, and you get these really big outliers. So what's going on there? That doesn't match the expectations. The climate models suggest fewer. Some suggest no change, but most of them suggest fewer tropical storms and hurricanes. What's going on? Another way to look at it is to use a metric called accumulated cyclone energy, where you take each tropical storm and hurricane and you square the winds to get a proxy for kinetic energy, and you add it up for the whole hurricane season. And so accumulated cyclone energy, or ACE, is really a much better metric overall for the activity, because it combines the numbers, the intensity, and the duration. And when you do that, that outlier for 2020, yeah, it was busy, but now it's the 13th busiest on record. And that long-term trend is there, but it's only about a 50% trend instead of a double. So something is telling us different stories here between total number of named storms, boy, girl, Spanish, French, and English names, versus this metric ACE. So why is it, an active year, but not crazy busy in ACE, but, the busiest by far for a number of named storms? And I think you have to look back at the technology and how that affects our records. And today we're so fortunate that if we're looking on marine conditions, that we've got so many tools to help us observe what's going on, whether it's the European scatterometers, whether it's buoys that are anchored to the ocean floor, whether it's ships that are going across the ocean. So for marine forecasting, we're very fortunate that we've got so many observations that are out there. In addition to the in situ measurements, we also have both the low Earth orbiting satellites that can look in the microwave spectrum and see through the cirrus, as well as the visible and the infrared imagery from the geostationary satellites. So both very, very powerful tools. So and also we have the hurricane hunters, both the NOAA P3s that are located in Lakeland, Florida, as well as the Air Force C-130s. And so these fleet of aircraft, they fly out there to measure 3 things. Where's the center of the storm? What are the strongest winds around the center? And how far in radius does the strong winds extend? And so today, if we have a tropical storm or hurricane, we know about it. There's no ambiguity about it, and we name it, and we write advisories. And so folks on the coast can get ready folks over the open ocean and ships can get ready. And so one thing we do at the end of the hurricane season is we take all those advisories and write up the storms, what are called tropical cyclone reports, and each hurricane specialist gets assigned a couple. Whether it's Robbie Berg or Eric Blake, all these other folks have retired recently. And so the database and the reports reflect the technology that you had at the time. And so this database, somebody once called it a byproduct of operations. And so what we're doing forecasts here at the Hurricane Center, but this database is a real important one that we maintain and update every year. So if you go back in time, how does those data change? So let's say 100 years ago, 1923, 100 years ago, there was no satellites, there was no radar, there was no hurricane hunters. All you had were ships out over the open ocean. And this was early on where they had radio. So before 1909, there was no way for even a ship over the open ocean to radio back to the coast that they were in a hurricane. The only way you found out about a hurricane over the open ocean was if that ship made it to a port. And so it was very fragmentary in being able to understand not only how strong the tropical storms or hurricanes were, but where were they? I mean, they were literally invisible. So we do have efforts where we're reanalyzing the hurricane database. I have a team that we're putting together, but you can't go back to 1923 and fly a hurricane hunter. We can't launch a satellite back in 1923. It doesn't exist. So we have very crude and primitive tools to go back in time to reassess the hurricane database. So my team and I, the tools we have are so crude and primitive, we feel like we're cavemen sometimes. That's me. And so, we're not under any illusion we can go back and have a perfect database. But we're doing our best with our caveman tools to try to make it as complete as possible. But it's always going to be incomplete. So this effort is called the Atlantic Hurricane Database Reanalysis Project. And there's the website, and I'll share the presentation with everybody if you want to check out some of the sites later. And what we've done is we've gone back all the way to 1851 and up through 1970. So we've had 120 hurricane seasons that we've revised, we've updated. We went back and got, for example, ships that they didn't know about at the time, or we've reassessed hurricane hunter data from the 1940s to the 1960s and said, if we had that hurricane hunter data today, how would we change it? And so we're still continuing these efforts. We're going to go up to about the year 2000. And so to me, this is a way we can make it a better database, but it's never going to be complete. And the reason is that the technology has evolved so dramatically that this HURDAT, this hurricane database, it's not just looking at climate and climate change, but it's technology change. In fact, the HURDAT may be the worst database for looking at how hurricanes change, because all of these changes, whether it's ships at sea, whether it was the hurricane hunters, the coastal radars, the polar orbiting satellites, geostationary, and all the rest, they all provide better ways for us to measure and monitor tropical storms and hurricanes. And that affects the database. It's an artifact in the database. And so it makes it really tough to really understand what's going on. And we even have artifacts in the last 20 years. So an example of that is a paper that I worked on with the folks up in Princeton, where we looked at shorties. So a shorty is a tropical storm that lasts for 2 days or less. I've given talks that lasted longer than 2 days. So these short-lived systems usually are weak, and usually they stay over the open ocean. And you can see in the database, there's very few of these back in the 1800s, early part of the 20th century. And then once the hurricane hunters started flying in the 1940s, started getting 1 or 2 a year. And in the last 20 years, we averaged about 5 or 6 of these per year, sometimes more. And so what's happening is the technology that's helping us is allowing us to name and issue advisories on systems that we would not have before. We wouldn't have known that they were tropical storms, and if we weren't sure, we wouldn't be writing advisories on them. And so just from 2020, there was at least 4 storms that were very, very unlikely to have been designated as tropical storms or subtropical storms in the past. And that would have been Alpha that hit Portugal. We would never have named that before. Edouard, Omar, and Dolly. All these very weak systems. Both Edouard and Alpha are ones that are hybrids that are subtropical, or subtropical is a blend between a tropical cyclone and extratropical. And so these shorties, this time series of shorties that shows this dramatic uptick, this is all technology driven, in my opinion. And indeed, a study by Gabriele Fiorini at Iowa State was able to confirm that this time series has no relationship with any real physical quantity. So what can you do then to try to figure out how are things changing? Again, the question was, are we having more storms or fewer, or are they staying the same? You can throw up your hands and say you can't do anything, but really there is some way to get around this issue. So first, you start with the raw database. And again, it shows the doubling from around 6 to 10 storms a year up to 15 to 20 now. And then you remove the shorties. So you take this time series out. And so what you're left with are the medium to long-lived systems that lasted for at least 2 days. And now you're starting to see some kind of decade to decade swings where it was busier and then quiet and then busier, then quiet and then busier. There still is a trend upward, but there's the issue of over the open ocean, you may have had a storm that lasted 3, 4, or 5 days before satellite and nobody knew about it. And so there's a methodology where you can estimate the undersampling. That is based on how many ships that are out there, and the colors represent the ship density. We can actually make an estimate of how many were missed. And so back over 100 years ago, there was a lot of shipping traffic from Europe near Africa, a lot from the United States East Coast to Europe, but very little in the Gulf of Mexico or Caribbean Sea. Once the Panama Canal opened up over 100 years ago, that really changed things. And there was a lot of traffic that started going from Europe and the United States through the Panama Canal. And so a lot more ships in the early part of the 20th century. But even in the mid part of the 20th century, there was still about a half to 1/3 of the Atlantic Ocean where there was no ships. No ships. Pretty much vacant. And so if there was a storm out there and it's before satellite, no one's going to know about it. It's not going to get in the database. And so there's an approach to add in the number of missed storms. And so when you do that, that long-term trend pretty much is gone, where you're adding in the number that were missed. And when you add in the uncertainty to that approach of that undersampling, then pretty much at this point, it looks identical. It was very busy in the late 1800s, very quiet early in the 20th century, busy in the middle part of the 20th century, quiet in the 70s, 80s, early 90s, and then very busy since 1995. So these kind of multi-decade swings back and forth after you adjust for, throwing out the shorties, which we're sure are technology driven, and adding in this estimate of what was missed before satellites in the 1970s. So one aspect that was interesting was in 2021, we introduced the new climate normals for named storms and hurricanes and major hurricanes for the Atlantic, Caribbean, and Gulf of Mexico. And the old average was, we could focus on hurricanes, was 6. And so now the new normal or average is 7. And so this reflects two things. One, that we're naming more storms because of the technology, but also it has been busy since 1995. And most of this 30-year time period is in that active period. And so that's important to keep in mind when one's comparing versus average. You have to ask, well, what's the base period that you're using to make that average? So if we ask the question, was 2020 a record-breaking hurricane season? The answer is yes, but so the doubling the number of storms over a century, that's technology change. That's not natural climate variability, and that's not man-made climate change. That's technology change. That's the database being corrupted, you could say, because of the improved technology. So 2020 did set a record for number of named storms, but other years like 1887 may have been just as active. And when you look at more meaningful metrics like accumulated cyclone energy, it's not even close to a record. And so there was a blog that I put together with Eric Blake that talked about that we put on the Hurricane Center website, and that link is there for you if you want. So, one can even go further and say, well, all right, well, that decade-to-decade swing that you're talking about, what's that going on? Is that real? And it does appear to be a valid fluctuation that's going on. And again, if we look at number of hurricanes and adding in the red the number that we think were missed, you can see very distinct periods of active in the late 1800s, quiet in the early part of the 20th century, active in the mid 20th century, quiet in the 70s, 80s, early 90s, and then busy again. So this busy, quiet, busy fluctuates on a 40 to 60 year cycle, a rough cycle. And when one looks at the sea surface temperatures over the Atlantic, it displays a sea surface temperature pattern where it's warm in the North Atlantic and cool in the South Atlantic. And the time series for that is a perfect match to the hurricane activity after you take into account the undersampling issue. That it was quiet in the early part of the 20th century, showing up nicely with that minimum there. Warm in the middle part of the 20th century, showing that there. Cold in the 70s, 80s, 90s, and matching that minimum there, and warm since 1995, matching the peak we're currently in. So this is called the Atlantic multidecadal variability. And when one looks at the physics behind this, it's not just the sea surface temperature, like we talked about earlier. It's the other factors working in concert. So in a warm phase of this AMM or AMO or AMV, there's different words for it, we not only have warmer waters, but we have more moisture and we have less shear. The dashed lines indicate less wind shear in the main development region, and that's where most of the strong hurricanes occur from. And then in the AMM negative phase, where it's cold, the shear goes up, and there's less moisture available, and it's more difficult to sustain deep convection. So this is different from the expectation of global warming, where in global warming, warmer water goes with more shear. So this is not a signal of global warming as best we can tell. So to summarize, if we're trying to look at what are the impacts by hurricanes from global warming by, let's say, the end of this century, assuming that there's a lot more greenhouse gases that'll continue to be emitted, and there's substantial global warming on the order of, say, 3-4 degrees Celsius, these are the impacts, roughly, that we may see. So the green is something that's actually beneficial, and the red would be not beneficial. And so the numbers could decrease slightly, but the increase in intensity is really tiny, roughly 3 to 5% stronger. Storm surge would also have a small increase, but any sea level rise would have to be accounted for as well. I'm going to have to take 2-minute break. I've got an urgent issue here. I'll be right back. So hold on, please.
Doctor Landsea.
Luisa, creo que mencionó una emergencia que necesitaba atender allá y que iba a regresar pronto.
Ok,
Vendrá un huracán entonces.
ok, le damos unos minutos, ¿no?
Sí, esperamos, claro. Fue una emergencia, dijo.
Ok, ok.
Por ahí viene un huracán, no sabemos nada.
Sorry about that. Got a child care issue I had to take care of. Okay, so let me continue on. So, how much time do we have? Or not sure if we have much more time or not.
Maybe 5-10 minutes, I'm not sure.
Perfect, perfect. Yes, I'll wrap it up then. So again, the expectations from the climate models in theory is that the numbers are expected to decrease with a moderate amount, and the intensity or maximum winds slightly stronger, storm surge slightly stronger, slightly more storm surge, but any general sea level rise is going to cause the saltwater flooding to be substantially worse. So, and there could be sea level rise on the order of a half to a meter by the end of this century. Rainfall, a moderate increase, so roughly 10% more within about 300 kilometers of the center. The overall amount of rain might be decreased, or it might be offset because of the decreased frequency of storms. And genesis and track are topics that are still quite unknown. The only studies that have been published so far suggest that storms may form slightly further away from North America, and so that could lead to a reduced number impacting North America and Central America. And if the tracks slightly could be more recurring ones that stay over the open ocean. But again, that's pretty preliminary results. And so this is my interpretation. Someone who's been in the field. I will say that my interpretation is pretty similar to what's been published by the WMO, the World Meteorological Organization, and the Intergovernmental Panel on Climate Change. And so these two papers that were published in the Bulletin of the American Meteorological Society are really nice ones because they summarize the field for hurricanes and climate change. And so I don't think what I'm presenting is outside of the general consensus in the field. It may be surprising because of the way that the media tends to portray things. So let me sum up, and then let's see if there's any questions. So first off, it looks like any man-made, global warming effects of hurricanes are going to be pretty small decades into the future. But what we have right now are very large decade-to-decade swings in hurricane activity. So, for example, major hurricanes, they double from 1.5 per year to 3 per year in the Atlantic, Caribbean, and Gulf of Mexico between these busy and quiet periods. So that's occurring now, and those are big impacts on a decade-to-decade time scale. The next thing is the vulnerability that we're going to see continue to have population growing along the coast in the United States and Mexico and Central America. So that means any impact from hurricanes could be worse because of the more infrastructure, more people there. And so what are some of the things that can be done? There are some steps that can be taken to decrease our vulnerability and risk. The first is to, what can we do on the meteorology side? And that would be to provide for better measuring of hurricanes, better modeling and forecasting. And so that's what we're working toward at the National Hurricane Center, is how do we better observe storms and get data from either satellites or hurricane hunters or unmanned aircraft to help us observe and get that data into the computer models so that we can have better forecasts of them. And so, but there's also changes that need to be made for building codes and land use. It makes sense that if you're in an area that can have strong hurricanes, to build to withstand the winds. So as an example, here in Miami-Dade County, any new home that's built has to have hurricane shutters, and so metal hurricane shutters. And so if you can prevent access of the winds into the house, then that really helps to decrease the damage. And then as far as when a hurricane does come, you need to have well thought out evacuation and shelter plans, and the elected officials and the emergency managers, they have to carry it out. And so those can be tough decisions. I would never want to have to be an emergency manager or a mayor or a governor and tell people they have to leave their homes. That's a really, really tough thing to ask. So I think I'll stop there and see if there's any questions. Hopefully the quizzes and the content were of interest to you and helpful. And again, this is something that I'm concerned about because I live here. I live on the coast in Miami, and it's not just an esoteric thing. This is something that affects myself and my family. So I want to know what's going on. So I'll stop there and see if there's any good preguntas para mí.
Okay, wonderful presentation. Thank you, Dr. Landsea. Emilio, vamos a empezar con Blue Jean y luego Facebook y YouTube, ¿no?
Okay. Blue Jean, entonces, Blue Jean.
Blue Jean, por favor, abran sus cámaras y sus micrófonos para poder preguntar.
Emilio,
Mira, está el doctor José.
Emilio, I have a question.
¿Cómo no entendí?
I have a question.
Yes, go ahead.
Se le escucha con eco, doctor Gómez.
Oh, sorry. I paso.
Pero diga, si se le escucha, puede preguntar.
Okay. Thank you, Chris, for your very nice quiz talk. I have a question. What about the Pacific Ocean? Is it also the same that you're talking about in this talk?
Yes, that's a great question. So it does appear that the modeling, the expectations are the same for the Pacific as it is the Atlantic. That in general, the numbers would decrease, the intensities would increase slightly, rainfall increase slightly. There certainly will be regional differences to how global warming impacts tropical cyclones, but I don't think we're quite there yet to try to differentiate them. As far as the observed record, it's more difficult in the Pacific because before satellite imagery in the 1970s, so many of the tropical storms and hurricanes west of Mexico were completely missed. There's not a lot of shipping traffic between west of Mexico, and so the database is only accurate back to the early 1970s, and even then, there are concerns about the quality of the database because the agency responsible for tracking all the tropical storms and hurricanes was a California forecast office in the National Weather Service of the United States, and it does not look like they did a very good job on estimating how strong the intense hurricanes were. So the National Hurricane Center took over the East Pacific responsibilities in 1988. So I think the database is accurate from 1988 onward, but that's only about 30 years, so it's not a long record to know what happens. The little we do know is that the Atlantic and Pacific tend to be vice versa. They tend to be opposite. When the Atlantic's busy, the East Pacific's quiet, and when the East Pacific's busy, the Atlantic's quiet. But yeah, knowing the long-term trend in the East Pacific is problematic.
Thank you very much. It is very, very nice explanation.
Thank you. Other question? Embruyen, pueden abrir sus cámaras, por favor. Doctor Farfán.
Sí. Chris, one quick comment or the new category of tropical cyclone, the potential tropical cyclone that started in 2017 at the Hurricane Center. Do you think that's needed, or I understand is something that helps the population have better warnings or do not wait too much before potential landfall? Do you think it's something related to some type of change, adjustment, or it's the environment that maybe having closer storms to the coast? Sometimes here in Baja California, or the western coast of Mexico, recent storms sometimes form 1-2 days before landfall. So I think it's a combination of several factors. Would you like to make a comment about that or your experience?
Right. Yeah. So the potential tropical cyclones are a forecast of a system to form and become a tropical storm along the coast. And so we've used that as a way to alert the public for both the United States and other countries that a tropical cyclone may form quickly, close to the coast, and cause tropical storm force winds. So it's a policy change, and to me, I think it's been helpful in alerting to the folks that you're likely to get tropical storm force winds. We do know that there's a lot more attention paid to it when we issue advisories, and so if we do that and not have a lot of false alarms, then I think we're providing a public service. Occasionally, we'll do a potential tropical cyclone, and it doesn't form, and that happened once this year in the Atlantic, and so it's that's the downside, is that we could have a false alarm where we issue advisories, we have a tropical storm warning, and it doesn't form. But we decided that was some downside that we could live with, because the overall benefit of better preparedness was worth it.
Thank you.
I have a question. Luisa, could you read me?
Oh, sorry.
Sí, Federico.
Adelante, Federico.
Thank you, Chris. Wonderful talk. Looking at the last slide, that it's still we can see it now. I wonder. You said that relatively minor man-made hurricane changes decades into the future. So, if I understand correctly, you don't see then these multidecadal lows and highs as we can see in the historic record. Is that correct?
Right. So those appear, after you take into account the undersampling in the database, to be very robust, where 25 to 40 years very active, 25 to 40 years very quiet. And there is some debate in the climate community on the cause, whether it's
Yes.
natural variability or whether there may be a role for anthropogenic aerosols. And so that's a very big debate right now. At the American Meteorological Society annual meeting 2 weeks ago in Denver, there was a wonderful session talking about just that topic. And there's a lot of debate on both sides on whether it's a purely natural phenomenon or one where there is some aerosol contributions or somewhere in the middle. Usually when there's a debate like that, the truth is somewhere in the middle. And so, but it's, and it's important to know what the right answer is going to be, because if it's completely or primarily natural variability, then we should go back to a quiet period. But if it's primarily aerosols that caused it to be very quiet in the 1970s and 80s, then we may not go back to a quiet period. And so my reading of the science is that it is mainly natural variability, but it's not a settled science.
Right, but if it's natural variability, wouldn't you expect to have these variations into the future?
Yes. Yes.
Yeah.
Yes.
Right.
And where it's been active in the Atlantic, Caribbean, and Gulf since 1995,
right,
and that we would expect it to be quiet like the 1970s, 80s, and 90s again. That is my expectation. Yes. The number one that I put on here, I really focused on global warming and greenhouse gases. So when I say relatively minor, to me that's where the evidence is pretty clear that the numbers would go down some, the intensities would go up slightly, rainfall go up a moderate amount.
Right. Okay. Thank you.
Thanks.
Thank you. Wonderful.
Thank you. Creo que levantó la mano Adam Mejía.
¿Sí? ¿Sí me escuchan?
Sí.
Okay. I have a question. It's about the changes in the area of generation of tropical storms. How will change with the due to global warming? And another thing is, you mentioned earlier on that the tropical storm may curve a bit more and will not affect so much the Atlantic coast, but that will be the opposite in the Pacific. Will affect more our coastal areas, or to get into the Gulf of California.
Right. That's a good question. So the change in genesis and the change in track were specific to the Atlantic. For the East Pacific, I'm not aware of any studies that have addressed how those storms will change. We do know that the physics is a little different, that you have a monsoon trough over the East Pacific, and it's a very active place. That's the most active place on the Earth, is south of southeastern Mexico for storms to form, because you have moisture, you have low vertical shear, and you've got a lot of low-level vorticity with the monsoon trough. But that's an important question. Yeah, if Genesis were further west in the East Pacific, then that would reduce the numbers or the likelihood of hurricanes hitting Mexico, because the further west that they form, the more difficult it is for them to recurve and reach the Mexican mainland.
Okay, thank you.
Thank you. ¿Alguien más? Pueden abrir sus cámaras y su micrófono en Blue Jean. Ok, hay preguntas en Facebook. Matthew, por favor. Matthew o Alejandro, por favor, de YouTube. ¿Alguno de los dos?
Okay. Hi, Chris. Thank you so much for your talk. I'm Alejandro. So there's a question in Facebook. Let me just
Okay.
quickly. and it's from Braulio Juarez. He says, thank you for your talk, and have you checked other records going back in time for a longer period, like using dendrochronological records or ice core records? And is it possible to obtain the number and intensity of hurricane events from those kind of records?
Yeah, that's a good question. So there's a field called paleotempestology, the study of prehistoric hurricanes, and there's a variety of ways to try to look at how often strong hurricanes have made impact on the coast. One way is to go to a coastal lake that is inside the barrier island, and take a pipe, hammer it into the muck, and you get a segment of muck, and most of it is black muck, but you have occasional sand layers. And so that's been interpreted as hurricane comes ashore, that blows the storm surge and the waves push the sand into the barrier lake, and you get these layers of sand. And so that approach has been used quite often to try to figure out how often strong hurricanes have made landfall. And that type of record is very useful for looking at century timescale changes, but not as much on year to year or even decade to decade. And so the results are a bit scattered depending on where they've taken records from, whether it's in the Caribbean or Mexico or United States. But that's one way that one can address prehistoric hurricanes. Another way that I've seen is with tree rings, where some tree species in the tropics are very vulnerable to hurricane winds or rainfall, and so there can be a record in the tree rings from hurricanes. Another way is that tropical rainfall has a different isotopic structure than hurricane rainfall. It's the amount of O18, I think it is. And so if you're able to get an estimate of how the O18 has changed from perhaps a stalagmite or stalactite, you can maybe get a record of hurricanes. So there's some very creative ways that geologists have tried to look at prehistoric hurricanes. Those are the three main ones that I've seen, but they haven't gotten a consensus on how changes have occurred in the past. And they can't really do year to year or decade to decade. It's more centennial and longer timescales.
Okay, thank you so much.
Thank you, Dr. Landsea. Matthew, please, there are many questions in YouTube.
Thank you so much for the talk. We have a question from Julio Martinez. A sea level rise due to global warming can enhance more intense hurricanes? Can you hear me?
Yes, I can hear you. Yes.
Okay. I repeat the question, or it's okay?
Okay. One more time, please. Un más por... Yes.
Okay. A sea level rise due to global warming can enhance more intense hurricanes?
Right. So the ocean temperature is just one factor in changing the characteristics of hurricanes. Because it's not just the temperature of the ocean, but it's the whole tropospheric temperature structure and humidity. And so yes, the sea surface temperatures can contribute to a small increase in the wind speeds and a decrease in the numbers of storms because of commensurate changes in the troposphere. But the storm surge is really the big change. And so if the hurricane winds cause a small increase of storm surge, but sea level rise is, say, a meter, every time you have a hurricane making landfall, the storm surge is going to be a meter more because of that sea level rise. And so the sea level isn't going to change the hurricanes themselves, but the sea level rise would affect the impacts of the hurricanes via the storm surge.
Ok. ¿Alguien más? ¿Alguna pregunta más? Para terminar. Okay.
Could I,
Sí,
Luisa,
dígame.
could I make a comment on what just Chris said about these sediments? I mean, this study with the cores in a lagoon. There is one theory that the Mayan civilization was affected by a huge increase, according to the records of this lagoon in front of, I think, Belize, by the year 900 or so. And that's a theory that they say that around that time, Mayan civilization was hit hard by a lot of intense hurricanes. Just a comment on that. That was in EOS 1 year ago or so.
I have heard about that study, but I had not read through it yet. But that's certainly climate change over time, you know, is a big factor in how civilizations come and go. So that would not be surprising. So I did put my email address, so if anybody has any follow-up questions, they could just email me there. I'd get back to them.
Oh, thanks.
Ok. Pues muchas gracias a todos por estar aquí. Thank you, Dr. Landsea, for your time. We will be in touch with you to send all your registration in the next week. Is okay?
Yes, that's fine. Yeah, glad to help, and thanks for the great questions, and I hope this was of interest to everybody. And I'll send off the presentation so you have access to that too.
Wonderful. Thank you.
Thank you, Chris.
Thank you.
Oh, thank you.
Thank you. Thank you.
Thanks.
Ok, Alina, ¿puedes parar la retransmisión en Facebook? Listo. Bueno, chicos, muchas gracias, Dr. Farfán.
A ustedes.